So much for joining me today. My name is Brandon Minnick, and in this session, we'll be talking about an introduction to serverless with AWS Lambda in C#. Now, I'm very excited to be here talking about this with you today because serverless is a topic that's actually near and dear to my heart. I'm actually a mobile app developer, so I wouldn't call myself a back-end expert. And I fell in love with serverless when I first published my apps to the App Store. I've been creating mobile apps in C# using Xamarin and .NET MAUI for about 8 years now. And when you go to publish your first app, you quickly realize every mobile app needs a backend, but also cloud can be really expensive. If you've ever spun up a virtual machine and forgot about it, we get a bill at the end of the month and whoops, never make that mistake again. And one of the things I love about serverless is, me as a mobile developer, I'm the only person who's writing the code for my app. And with serverless, there's much less stuff for me to maintain. AWS just kind of makes sure everything stays up and running for me. And then also with the cost, I don't get this massive bill at the end of the month. And this is great because my apps are free to download. I've never made any money off the apps in the App Store. So it's an awesome way that I can have a backend running in the cloud and still be able to serve my apps for free in the App Store. So we'll get into all that today. But before we do, I want to highlight a couple links here on the slide. If you have the chance, make sure to take out your camera and grab a picture of this one right here, because codetraveler.io/.net-serverless is a webpage where you can find everything that we're going to cover today. So don't worry about memorizing anything. You don't even have to worry about taking notes, because if you just go to that link, the QR code will also take you there. But that's where you can find a recording of this talk. That's where you can find the slides. That's where you can find the code that we're going to be playing around with. And I've also included a bunch of links. So if you want to continue on your journey learning serverless, making AWS Lambdas, then you can find it all right there. And on the bottom left here, this is my Twitter handle. You can find me online at the Code Traveler. So I'll be around at the conference the rest of the day today, all day tomorrow. So if you have any questions, we can always chat and catch up. But if for some reason we're not able to sync up and you want to follow up, feel free to reach out to me on Twitter. My direct messages are always open, and I'm always on there chatting about C#, mobile, .NET, cloud, all that fun stuff. So come on and join the conversation. Now, what is serverless, right? Because serverless has kind of become this buzzword lately. Well, not lately. It's been around for a couple years now, but I've kind of found anytime something becomes a buzzword, it starts losing its meaning. People kind of start saying it all the time. But when I first heard about serverless, I was like, what? That doesn't make any sense, because we know as developers, our code needs a server to run. Our code has to run on a server. It needs a CPU, it needs memory. But with serverless, you're telling me that there's no server? And that doesn't really make sense. So for me, what I've found a better way to think about serverless is not that there's no server, but rather that there's less server. There's less server for us to have to maintain and manage. There's less server running in the cloud that we have to pay for at the end of the month. So with serverless, yes, our code still runs on a server. It's not this magic thing that defies physics where all of a sudden our code can run without a CPU. It's just that we're using less server, and we, as a benefit, have to manage less server as well. But let's go way back. If we go way back to the time before cloud existed, everything was on premise. And I started my career only about 15 years ago, so I don't think I'm that old. But when I started out, there was no cloud. Everything was on premise. Every company that I worked at had massive data centers, and it was a pain in the butt to do anything, because if you just wanted to create an app, well, the first thing you had to do was get the team together and figure out how much server you needed. And then once you figured out how many users you expect, then you'd place an order. Server would arrive on my desk 6 to 8 weeks later. I'd have to take that down to the data center, rack and stack it, cable it up, and then I'd have to work with the system administration team to get the operating system installed and up to date. I'd have to work with the security team to get it all locked down so we could put it online. The networking team would have to install the DNS and all the routing tables and all that stuff. And it was just a pain in the butt. And fortunately, around that time, Amazon kind of looked around and said, hey, we've got a ton of servers, because Amazon.com. And if we look at it, not all these servers are running at 100% capacity. There's a lot of idle CPU cycles that are being essentially wasted. They said, what if we allowed people to essentially rent space on our servers And with that, they came up with this concept that I like to call cloud infrastructure, where the first iteration of cloud was I could go to AWS and say, hey, I need a virtual machine, and I want a 4-core CPU, 16 gigs of RAM, and now with a couple clicks of the mouse, I could have a server up and running for me in the cloud. I didn't have to wait 8 weeks for it to arrive at my desk. We didn't have to worry about, do we buy a big enough server ahead of time? Like, what's our scaling going to be? Because all that was managed for us in the cloud. But yes, this is great, but I'm still managing this server. So I still have to have my system administrators install the latest version of Windows, has to keep up to date with the security patches. I got to make sure my security team's locking down the networking, and I've got to do all the routing and DNS stuff myself. So way more convenient than having to buy your own server, way more convenient than having to rack and stack it yourself. But with cloud infrastructure, we're still managing servers. And the next iteration came about, and this is what I like to call cloud platforms. So this is something like with Elastic Beanstalk, I no longer have to worry about an operating system. I can just say, hey, AWS, I've got an ASP.NET Core web app that I want to run in the cloud. I can right-click publish. I tell AWS that, yeah, I want to rent out a 4-core CPU, 16 gigs of RAM, and it's as easy as that. I don't have to worry about the operating system. AWS takes care of the security patches, takes care of the routing and the DNS stuff for me. So life got a lot easier with cloud platforms like Elastic Beanstalk. But the problem is at the end of the month, you still get a bill because you're renting space in their data center. So you're telling Amazon, telling AWS, I need 4-core CPU and 16 gigs of RAM. And they go, sure. And just like how I'm here right now in Sydney, I'm from California, but I still got to pay rent at the end of the month to my landlord, whether I'm there or not. Same is true with cloud platforms like Elastic Beanstalk. So whether your users use your app or not, whether they're only awake during the day and they're all asleep at night and nobody's using it, you still get a bill at the end of the month because you've told AWS, I need 4-core CPU, 16 gigs of RAM. So finally, we get to the final iteration where we introduce serverless. And with serverless, same concept as the cloud platforms where we don't have to worry about operating systems, we don't have to worry about security patches, we don't have to worry about networking. We can just focus on our code and publishing it to the cloud. But the really cool thing with serverless is now I don't even tell AWS how much I need. I don't even have to tell them that I want this many CPU cores and this much RAM because they're going to take care of that for me. So with serverless, if I have, let's say my app goes viral, right? I get 1 million downloads, it'd be an incredible day. And that's okay because AWS will scale up my serverless instance to handle that load. And likewise, when all my users are asleep in the middle of the night, they scale it all the way down to 0 so that I don't have to pay for it when I'm not using it. So with serverless, we're able to vastly reduce our monthly bill. And the best news is it'll still scale up and down to handle whatever demand and our users might have. So why do I love serverless? Well, it abstracts away the servers, because again, I'm the only developer working on my mobile apps. I'm the only developer that's working on the backends, and I don't want to have to manage operating systems. I don't want to have to install security patches. And with serverless, all that's done for me. I don't have to worry about any of this stuff. Instant scale. So if, again, my app goes viral, AWS will scale up to handle that load. And then when all my users go to bed, it scales down to 0, which means I don't get a massive bill at the end of the month because I only have to pay for what I use. Now, this is where we start getting into the nitty-gritty and some caveats because, yes, it's great that AWS spins down my instances to 0 if nobody's using it because it'll lower our bill at the end of the month, but it introduces this concept of a cold start. And so if you think about it, this does make sense. Like, if nobody's using my app, AWS scales all the instances down to 0. Nothing's actually running in the cloud. My code's still kind of there. The event triggers are listening, waiting for that next HTTP request. And when they get it, they're going to wake up. So let's say you wake up at 6 a.m., you're the first person to launch my app. Well, you're going to hit what's called a cold start because when that HTTP request happens, when that trigger wakes up my code, well, AWS has to quickly allocate some CPU, some memory, and then .NET also has to spin up and run my app. So with .NET 6, this used to be more of a bigger deal. We were seeing cold start times of about a second. But I will say, even with that, I've been using serverless for my backend for years. My apps still, thankfully, have 5-star reviews. I've never gotten complaints. So for mobile users, we're pretty flexible. We're kind of used to like poor internet connections, like conference Wi-Fi's, or we're on the bus and we're switching cell towers. So mobile users are a little bit more forgiving, and they never noticed that 1-second cold start delay. But now with .NET 7, .NET 8, thanks to AOT, we're seeing cold starts drop down to about 300, 400 milliseconds. And to me, this is completely negligible. Like literally, to blink your eyes takes about 300 milliseconds. So if some of my users get a cold start penalty of 300, 400 milliseconds, I don't even care. They probably won't even notice. But the good news is we have the data that showed that the majority of your users, about 70 to 80% of your users, will hit what's called a warm start. And that's because, let's say you woke up at 6 a.m., you launch my app first, you get this 300 millisecond cold start penalty, but then I like to sleep in a little bit, so I wake up at 6:05, launch the app. Well, that instance is already up and running, so I experience this warm start, which now we're talking 9, 10 milliseconds, whatever, no big deal. So the way this works is, yes, the first user to trigger your serverless backend will experience this cold start, but AWS keeps that server instance up and running for about 15 minutes. So until it's idle for about 15 minutes, they won't scale it back down to 0, just in case another user comes along. So again, the good news is the majority of your users will hit what we call a warm start, but it is something important, something to keep in mind, because it may impact your business. Now, it's tough nowadays to think of examples, but let's say you work in finance, you got to make stock trades, right? So that stock trade doesn't happen right away, then your company could lose millions of dollars. Well, yeah, that 300 millisecond cold start could be pretty bad. But I'd argue probably 90, 95% of apps, users will never notice a 300 millisecond cold start delay. Now, I do want to highlight, you'll see the numbers drop massively right here. And this was because in .NET 7, the team at Microsoft introduced something called native AOT. AOT stands for ahead of time compilation. And this is one of the ways we're able to get this drastic decrease in cold start times. Because if you've never heard of this before, you might be thinking, well, wait a minute, every time I write code in C#, I've got to compile it. So my code's always compiled ahead of time anyways, right? Well, what actually has always happened since the history of .NET was when you click compile and that DLL is created, your code actually just goes down to what's called the Microsoft Intermediate Language. The compiler doesn't actually generate assembly level ones and zeros, like the code that actually goes to the processor. It creates MSIL, and then it's not until your app runs and when it launches, the .NET runtime looks and sees, okay, what CPU are you running on? Okay, well, now I'll quickly compile that code into assembly level, into ones and zeros for that specific processor. And so with native AOT, we're now able to tell .NET ahead of time, hey, you know what? Go ahead and just compile it all the way down. Let's skip this whole intermediate layer and just compile it down to assembly level, down to ones and zeros. And with that, now our cold starts get down to 400, 300 milliseconds because .NET doesn't have to essentially just-in-time compile based on our CPU architecture that it finds running on the server. Something also really cool, in .NET 8, they added these properties we can add to our CS_proj file. So if you right-click, edit your CS_proj, you can specify an optimization preference for native AOT. So you can tell the compiler, hey, I want to optimize size, or I want to optimize speed. And the compiler, if you say size, will try to look to see like, hey, is there any code that, yeah, these files exist, but I don't think they're actually touching this code, so we can remove that. So if you optimize for size, it'll make that DLL a little bit smaller. And if you tell it optimize for speed, then of course it's going to look for little ways to optimize the code we wrote to make it a little bit faster. And they introduced this ILC instruction set property. So again, in your CS_proj file, you can add ILC instruction set. And if you know the server you're running on, it's like, for example, if I know I'm pushing my code to AWS Lambda and I'm running on x86, I can specify the Skylake processor, that's the instruction set that Intel uses. And it'll optimize our code even further, because whether you know it or not, the reason CPUs are different is because they have different instruction sets. And so some CPUs can do things that other CPUs can't. And again, if we can specify that in our CSproj file, now .NET can optimize our code even further, so our app will be a little bit faster. So again, something to keep in mind. But nowadays, with .NET 7, .NET 8, thanks to native AOT, we're seeing cold starts dropping down to about 300, 400 milliseconds. Does that really matter? Probably not, unless you're in that strange edge case where, like I said, you need that stock sale to happen right away. But all of this gets us to my favorite point, and it's what I like to call micro-billing. These are the actual apps that I have in the App Store, so shameless plug. If you have a lot of GitHub repos, I created this app called Git Trends because I too have a couple hundred open source repos that I manage, and I needed an app that would show me the stats. So like how many views, how many clones, what's the star history, where's the traffic coming from, like how are people getting to my app? So Git Trends will help you manage and monitor your GitHub repos. And Punday, if you're a fan of puns, if you're a fan of dad jokes, Punday is something I teamed up with a buddy. He makes these fun drawings, and they're all puns, so you got to guess them and try to figure it out. So like one of them is there's a picture of, it's like a really hairy caveman working at a pottery wheel, making a clay pot, and the pun is Harry Potter. So like I said, shameless plug, download them, give them 5 stars, please, thank you. But this is the actual data. I pulled this from my usage back in January. And so for Git Trends, I had about 79 monthly active users, and my serverless cost on my bill at the end of the month, 14 US pennies, basically free. And then with Punday, I've got a couple more users. I mean, still not Facebook billion level, but a couple hundred monthly active users, and that monthly serverless cost was only 19 cents. So super, super cheap. I've got the fine print right here. If you squint, you can kind of see it's 0.000013 US dollars per gigabyte second. And then every million requests, they charge you another 20 cents. So this is how I'm able to still have apps in the App Store that are free to download without having to, mortgage the house every month to pay our cloud bill. And again, it's because when nobody's using my app, my serverless instances scale all the way down to 0. Okay. Now, probably the coolest thing with serverless is this concept of event-driven triggers. Now, the stories I've been telling and my most common use cases have all been kind of around this HTTP trigger. So like I have an API, it's running on a serverless instance, and it uses an HTTP trigger, like an HTTP request, to wake up and quickly run my code. But if you're using AWS, and let's say you're using something like S3, so a storage bucket, blob storage, where you can store files, well, you can have an S3 trigger wake up and run your serverless app. Likewise, let's say you have a DynamoDB database. You can have a database trigger wake up and run some code. Like, let's say a new user signs up for your app. You add that user to the database. Well, you can have a database trigger wake up, and maybe we send that user a welcome email. And the thing I love about this is before this scenario really existed, we always had to do like batch jobs, right? Like there'd be that overnight cron job you'd run that would maybe clean up the database, or maybe once an hour you'd have some code run. Well, now we can have these events run as soon as something happens and kind of get that response to the users, better user experience, and everything's much, much better thanks to these event-driven triggers. Okay, so enough talking about it. Let's actually check out some real-world code. And like I said, this is all open source. I've got the link to it here on my website for you. But this is a sample that I've made for us today. And I've created a mobile app in C# using .NET MAUI that takes your picture, and we're going to upload that to the cloud. And it's a pretty simple example, but it's something that pretty much every mobile app does, whether you know it or not. Like when you take a photo and upload it to Instagram, Instagram takes that 48 megapixel photo you gave them, and then they scale it down because that photo is going to be massive, right? And they're not going to serve a 48 megapixel photo to all of us like every time you come look at my Instagram profile. What they do, they scale down these photos to fit certain screen sizes. So when I launch Instagram and it goes and pulls down photos, Instagram first looks at the screen size of my mobile device and says, okay, which photo is going to look best? And then they'll serve me, maybe a 124 by whatever resolution photo instead of the actual original one, which is better for all of us because if they were serving us 48 megapixel photos that our cellular data plans would burn through in a heartbeat, it'd take forever to load pages. So this is what we're doing today. We're going to take a picture, and then I have a Lambda with an HTTP trigger. It's basically just a post API that I've named upload image. And all that serverless function does is store that image into an S3 bucket. Now, once that photo is added to the bucket, I have an S3 trigger that wakes up this Lambda called generate thumbnail that'll take the picture that I've uploaded, shrink it down to 200 by 200 pixels, and then save it back to my S3 storage bucket. And then now, when the app requests that photo, instead of serving it that same huge photo that I uploaded, they'll get the smaller 200 by 200 pixel thumbnail. So let's check this out. And we'll go ahead and run it first. And since I'm on an app, or since I'm on a Mac, yes, this is made in .NET MAUI, so this will run on iOS, Android, macOS, and Windows. But since I'm here on my Mac and we need to use the camera, we'll just run the macOS app instead. So we'll take a picture. And when I say use photo, it's now uploading to the cloud. We have our upload image API that's taking this, storing in the S3 bucket. Then the S3 trigger wakes up that generate thumbnail function, creates that 200 by 200 megapixel photo. And let's see, how's our Wi-Fi doing? Let's try it one more time. So right, so that S3 trigger should take that, generate our thumbnail, and then as soon as that's done, we'll see the smaller thumbnail appear here. There we go, okay, perfect. So what I want to do is run it one more time because what we saw there, it actually timed out, because I probably should have tested this on conference Wi-Fi, but we were hitting those cold start delays. But if I run it again, instead of taking, what was that, 5, 10 seconds the first time, we'll hold up 2 fingers this time. That way we know it's a different photo and we're not cheating. Then we'll get through this whole workflow faster because all of those serverless instances are already warmed up. So the first time, cold start, second time, warm start, and we can see that here. Now, let's actually jump over to Visual Studio and look at the code. So what I have here in my Solution Explorer, we've got a couple folders. So again, the mobile app created in .NET MAUI. We've got our backend. So this is where I've got the upload image, get thumbnail, generate thumbnail, serverless functions. And then because they're all written in C#, there's some code that we can share between the backend and the front end. But let's first look at this code in upload image. And there we go. And so if we just scroll down, this is all the code. This is it. There's only about 74 lines of code in here. And this is what we want, because with serverless, we want our code to do one thing. We want it to get in, we want it to get out, because one of the things that will happen in serverless apps is if our code runs for too long, AWS Lambda just cuts it off. I think the cutoff's like 10 or 15 minutes. So we don't want long-running code for our serverless applications. We just basically want to write a function that does one thing, in this case, ingest that photo and drop it into the S3 bucket. Because if our code runs for too long, AWS will be like, nope, this is a bad use of serverless. And if something is going to run for 20, 30 minutes, an hour, then serverless probably also isn't a great candidate for you. But if we look at the code here, it's pretty straightforward. So we have this one method called function handler, where we have a API gateway, HTTP, API v2 proxy requests, it's just a really long name for the HTTP request that's coming in. So what I do is I just first check the query parameters. I make sure that they're valid. If they're not, I'll send back a response with a bad request. But all we're doing here is I get the image, I upload it to S3, I add some information to the logs that said, hey, this was successful, and then respond with an HTTP OK. Unless something does go wrong, then we'll respond with a 500. And this is basically it. But I do want to highlight something here, because one thing that's really cool about having all this run in the cloud together, so my S3 bucket and my serverless functions running together, means that I can just say new Amazon S3 client here. And because it's all running in the cloud, I don't have to worry about security, permissions. Like when you spin up an S3 bucket, it's private by default. So nobody can access it except for you if you have the credentials. But since this is all running in the cloud together, I don't actually have to pass in any security credentials. I don't have to do anything here. It's all handled for me thanks to AWS. So with just a couple lines of code, we upload this image and we save it to our S3 bucket. And then if we look at our generate thumbnail code, pretty similar. Again, super small file. What do we have? 80 lines of code this time. So basically nothing in here except this one function. And this, the big difference here is we have a S3 event that's triggering this function and waking it up. So the last one was an HTTP trigger. This one's an S3 trigger. And this says every time a new file is added to my bucket, then wake up, run this code, where if we look at it, what we do is we get this S3 event. We look to see, is it already a thumbnail? If it is, we'll just return. Don't need to do anything there. If it's not, then we'll go to S3 and we'll get the object. Because for whatever reason, this S3 event doesn't actually include the file. It just includes the metadata about the file. So I tell my code, okay, here's my S3 bucket name. Here's the name of the file, the key, which is just the file name. So it goes and gets the file. We copy it into a memory stream, generate a thumbnail, and then upload that thumbnail back to the same S3 bucket. And lastly, we've got our get thumbnail image, which probably can already guess what's going on here. We've got our HTTP API v2 proxy request, where we just check to make sure everything's good. If not, send it the bad request. And then this just gets the thumbnail from our S3 bucket and returns it back to the user. So pretty straightforward. But what I want to do is actually create one of these together with you today. So first things first, if you've never used this extension, make sure to go get it, because there is the AWS Toolkit extension. There we go. So the AWS Toolkit for Visual Studio, if you're an AWS developer using Visual Studio, this will save your life. Everything we're doing in this demo is basically thanks to the AWS Toolkit. So highly recommend it, because this is where you can get templates for the serverless apps that we'll be making today. You also get this AWS Explorer, which is really cool. So like this is connected to my AWS account. And for example, I can see the actual AWS Lambdas that we're running in the cloud that process that photo. So I can do things like I can right click on upload image. I can look at the logs. And without ever having to go to the AWS console, here in Visual Studio, I can just see, well, here's the logs from the latest event. If you line up the timestamps, you can see I'm not lying. This is where it uploaded the image to S3, and we got the okay, everything worked. Even like we can look at our S3 bucket. So the bucket I use for this app is called Lambda Triggers Bucket. And if I double click on this, then we can see the actual files in the bucket. So again, without having to leave Visual Studio, without having to go to the AWS console, for example, I can double click on this image. It'll launch my browser. And there we go. There's the image that we just took together. And there's the thumbnail as well. And this is really cool because again, those AWS buckets, they're private by default. But when you click on these, if you dig into it, you can see that it gave me all this special access to it. So it gave me a link that's going to work for a short amount of time that already has my credentials. And because everything's already connected, AWS Explorer, AWS Toolkit knows me, then it trusts me. And this is really cool stuff. So with that being said, let's jump into it. Let's create our first function. And what I'm going to do is just say add new project. And if you want, you can just type in AWS here in the search bar, and you can select one available here. But what we're going to do today is just AWS Lambda project, .NET Core, C#. They should probably drop the core part in there because this is going to use .NET 8. And yeah, we'll call it AWS Lambda 4, no problem. And then we get this pop-up with a couple templates that we can use. Now, the one I always use and the one I recommend is this custom runtime function. And let me explain why. So with AWS Lambda, they have what they call managed runtime. So what we could do is just write our code and give it to AWS and say, run it using your version of .NET. And that'll work, no big deal. But AWS Lambdas, their managed runtimes, they only support the LTS releases. So like if you've already written your app in .NET 7 and you want to run that on AWS, you want to use this custom runtime function where it'll package it all up together, including the .NET runtime. And the reason I recommend this is because now you don't have to wait for the Lambda team to catch up. Like, for example, .NET 8 support is there in preview right now. We're actually going to promote that this month. So in a week or so, you can have the .NET managed runtime there for you in AWS Lambda. But like .NET 9 preview just came out today. Like .NET 8's been out for months, right? Like, why would you want to wait so long? So I always recommend, and I always use this custom runtime function. So that way you can bump up to .NET 9 as soon as you want to. You don't have to wait for the managed runtime to catch up. So let's select that. And now what it's created for us is kind of what we expect, based on what we were looking at a minute ago, where we have this file that super short. There's just one function in here called function handler, and our static async task main method that kicks off the method. So let's see. First things first. What I want to do, I want to create a post API where we'll just upload some text. We'll save that text to a file in S3, and then we'll call it a day. So first things first. If we look here, there's a couple of NuGet packages I need to add to this new project, and I never memorize the names of these, so I'm going to cheat a little bit. And the first one we're going to add is this Amazon Lambda API Gateway Events NuGet package. And then because we're also using S3, I'm going to add in this AWS SDK.S3 NuGet package. So let's do that here. Let's say manage NuGet packages. Let's browse. Let's say API Gateway Events. Hopefully that's enough to, there it is. All right, so we'll install that. And then we also want to install that AWS SDK.S3 NuGet package. There we go. So I'll add that to our project. And then I'm going to cheat a little bit so we can save some time, because I already have this class that I made for the sample app called S3 service that has some helper methods in it, like this one that I named upload content to S3, where this just uses that Amazon S3 SDK client. But I added a little bit of a helper method here so that, if the content is a stream, you got to handle streams a little bit differently than if it's just like a JSON blob. So we'll just copy paste this code into our new project. Copy, paste. And then what I'll do is just delete some of this unused code that we needed for the sample app that we're not going to use. And the one we're creating today. So that looks happy. Okay, and now we can start writing our new function. So let's start out by saying this isn't going to be a string input. It's going to be an HTTP come on, IntelliSense. Let's see. Let's make sure that NuGet package installed. Yep, API Gateway event. Okay, there we go. Just API Gateway. Let's see. So this will be our request. So API Gateway HTTP v2 proxy request. Done. So that's our input. And then instead of returning a string, we're going to return a task of type API Gateway proxy response. And then, of course, we want to make this async. So now we've got our input. And the first thing I want to do is I want to get the content from that body of the HTTP request. So let's create a variable called content. And this will just be input.body. Great. And then we want to upload this content to S3. So I'll say await, and I'll use my S3 service and say upload content to S3, where we need to pass in that S3 client. So let's go ahead and create that. So we'll say static read only I S3. There it is. I Amazon S3. We'll name it S3 client. There we go. All right, so we'll pass in the client. And again, the client's the one that already knows all our credentials. And just by saying new here, it's already basically validated everything for us in the cloud. And then the next thing we need to add is the name of our bucket. So I haven't created a bucket yet, but let's do that now. So again, super cool. And with the AWS Toolkit, I can just go to my solution or my AWS Explorer. I'll say create bucket, and let's name this NDC Sydney. There we go. and that's gone ahead and created a new S3 bucket for us in the cloud. So now I can tell you that I've got a bucket named NDC Sydney, and that's where we're going to put this file. And then we need the file name, so the key. And for that, why don't we just create a GUID, right? We'll just say GUID, new GUID, toString. That looks great. So that'll be our file name. And then the content will be the content we got from the body. And then we'll pass in this Lambda context. .logger. Perfect. So this API triggered. We created a file name for it. We got the content out of that HTTP request. We saved it to S3. So now all we need to do is return a new API gateway proxy response. And here, this method will actually give us the URL. So why don't we go ahead and grab that URL here. And then for the status code, we'll just say, yep, everything was good, 200. And then the body, we'll just go ahead and deserialize that. So we'll say JSON serializer, serialize that URL. Whoops, there we go. Okay, that's it. So we've just created our first serverless function. And again, thanks to the AWS Toolkit, I can just come over here to our AWS Lambda 4, say publish to AWS Lambda. And again, without having to ever leave Visual Studio, I can tell it I want this to run on ARM. We'll call this, how about hello NDC. Say next. It quickly validates to make sure that hello NDC is a valid name for my function, make sure nobody's taken it yet. And then we have to give it our IAM permissions. So I've already done that ahead of time. And actually, pro tip, I almost forgot this. Before we can do that, we should make sure it builds. So let's go ahead and build the app, make sure we don't get any errors, because if we do, okay, great. So now we'll do the same thing, come back in, ARM, hello NDC, validate the name, make sure it's good. Hopefully it still is. There we go. Select our IAM role, click upload, and now this is basically running .NET Publish, and then it's going to take my code and publish it all to AWS for me. I don't have to do anything. I don't have to jump down to the command line. I don't have to go to the AWS console. All of this is happening for me thanks to the AWS Toolkit. So again, highly, highly recommended if you haven't used it yet. And in just a second, this will finish, and we'll see one more step we have to do, where we will have to go to the AWS console for just a minute. Okay. So that's created, and we can even verify that here in our AWS Explorer. So there's our hello NDC brand new AWS Lambda that we created. And if we jump over, I'll look at the AWS console. And here, we'll go to our Lambdas. We should see our brand new hello NDC. There it is. And the reason we have to jump in here is we need to specify its trigger. So this is where we say add trigger. And if we wanted an S3 trigger, if we wanted the DynamoDB trigger, this is where we would wire everything up. But for this example, we're just going to do API gateway, and we'll tell it to create a brand new API for us. And yeah, we'll just leave it open. You know, if we were better developers, we probably would lock it down, but no need, right? This is this is just a fun demo. And now it's created this API gateway trigger. We have this API endpoint that I can take this, I can jump into Postman, and we can start using it. So this is live. I can create a new JSON body where maybe we pass in text and we say hello NDC Sydney, and maybe we'll give a little wave. There we go. And when I click send, this is now sending it to our serverless function. This is live. This is running in the cloud. That serverless function is saving it to our S3 bucket. And then, like we saw when we created the code, it sends back this URL. But you know, if I click this URL and tries to open the browser, good, it's going to deny me because again, all your stuff in S3 is private by default. So I'd be a little nervous if I was able to access this without the proper credentials. But if we jump back over to Visual Studio, now we can see here that we can click on our hello NDC function. We can view its logs, make sure that it actually did run, right? So there it is. You know, here you go. it ran right now. And if we want to, we can even jump over to our NDC Sydney bucket that we just created. I can double click this, and then this will let me open up in the browser. And there's my hello NDC wave. Did I really forget to remove the word wave? That's funny. So just like that, with a couple lines of code, a couple clicks of the mouse, thanks to the AWS Toolkit here in Visual Studio, we're able to create a live serverless function. This is a public API anybody can access right now, and everything's up and running in the cloud. So super, super simple, super, super easy. And again, this is why I love it, because as a mobile developer, I don't want to have to manage anything in the cloud. I don't want to have to worry about, what if my API goes down? Well, you don't have to worry about that. AWS will make sure it gets up and running for me. What if I get 1 million users? Don't have to worry about that. AWS will make sure everything scales up accordingly. So make sure to get that AWS Toolkit extension, because if I'm being honest, I don't know how I would survive without it. Highly, highly recommend it. Now, what you might be thinking is, okay, that's pretty cool, right? But we're .NET developers. That wasn't enterprisey code. I was using public statics. I want to use dependency injection, or I've been making APIs in .NET Core for years now. Why don't I have attributes and I can specify routes? Well, there is a really cool NuGet package available called Lambda annotations. And with Lambda annotations, we can take their function codes a step further. And you can see here, we're able to now add these attributes. So just by saying Lambda function, it'll use source generators to generate all that code that points and tells AWS where to find the code that we wrote. We can also specify that it's an HTTP API, and we can say this is going to be a put API. So if a GET request comes in, that's a bad request, reject that. Only allow put requests in. We can specify the routes, so we can say /process. We can specify a variable here, name, that string name will get injected here into the method. With dependency injection, if we want something from our IOC container, we can just say things like from services, and then again, that'll get injected into this method function. And then down here, we cheated a little bit in that example. I didn't actually deserialize what came through in the content body, but with Lambda annotations, we can just say from body, just like we do in ASP.NET Core. It'll automatically deserialize what's coming in into whatever C# object we're using. So highly recommend this because it does make our code a lot easier to read, a lot more manageable, and a little bit more intuitive to what we're familiar with. But what if you've been using ASP.NET Core for years, right? You've already got these existing apps running in ASP.NET Core. You would love for them to be serverless, but you don't want to have to rewrite everything. Well, check this out, because there's another NuGet package you can add to your app that you can take an existing ASP.NET Core app. This is actually one that I have running in the cloud. This is a GraphQL API that I created for one of my apps. And all it is the same ASP.NET Core we know and love. So whether you've got a website or an API, whatever it might be, if you just add in this one line of code, you just say builder.services.add AWS Lambda hosting, this can now run in AWS Lambda. So if you just want to take your existing web app, run it in a serverless instance, you don't have to change anything, because behind the scenes, when you add this line of code, what the AWS Lambda team does is they just replace Kestrel with the managed runtime in the cloud. So if you, again, already have existing APIs, if you already have existing web apps, you can even take those and publish them up to a serverless instance as well. Okay, so now's the time. If you haven't had a chance yet, make sure to take out your phones, grab a picture of this slide. You can use this QR code to get to my website, codetraveler.io/.net-serverless. Because again, this is where you can find everything from today's session. So you'll find a recording where I've presented this at a previous NDC conference. You'll find the slides. You'll find links to everything. So if you want that Lambda annotations NuGet package, I've got a link to that. If you want to grab that NuGet package that allows you to serverlessify your ASP.NET Core existing app, we've got a link to that. So also, that code is all available. That Lambda trigger sample where we took a picture, we published that to the cloud, that's all available to you. So make sure to bookmark this link. You can share it with your coworkers, maybe who couldn't be here today, and you can help them become experts on AWS and serverless just like us. Thank you. looks like we do have a little bit of time. Happy to answer any questions. It's also the lunch break, so you won't hurt my feelings if you're hungry. I'm a little hungry myself. Yeah, go ahead.
You showed us the AWS Toolkit, right, for Visual Studio. I guess in a actual work environment, I don't think you'd be allowed to directly use that. So in terms of the CI/CD configuration, how easy is it to use?
Yeah. Fair point. Good question. I've got a buddy, Damien, who says, friends don't let friends right-click publish. I mean, I do all the time because I'm a mobile app developer. I don't care. But yeah, so there's absolutely command line tools. I don't know if anybody's familiar with the Amazon CDK or the AWS CLI. All these work together, so you can absolutely do everything in your CI/CD pipelines. If you'd rather not right-click publish and you prefer to work in the terminal, they're all there too. So yeah, plenty of options. You're not going to be limited by that. Good question, though. Thanks. I should probably show that off. To be honest, I was a little worried we run out of time, which is why I just showed those last 2 slides of code at the end. But great question. Thank you. Yeah.
Following a similar line, if you need to manage that across multiple environments, across tests and stuff like that, with sort of known endpoints that you could call from other parts of your system, is that sort of well supported?
Yeah, I don't know if you heard of, there's CloudFormation in AWS where you can basically create the infrastructure. So you can tell it like, we want to have these serverless functions connected to this or these S3 buckets and this database. You can kind of wire it all together. Yeah, you can absolutely use CloudFormation with all the same tools and it'll all work together. In fact, there's something called the serverless application model. Let's see. Yeah, we can show off something real quick. So you might have seen when I said add new project, and we just type in AWS, there we go. So the options we get, and this was a little confusing for me at first because, yeah, okay, AWS Lambda with Node, AWS Lambda project with C#, yeah, that makes sense, F#, okay. But then if we scroll down, whoop, too far. Then you see the same thing again. It says serverless application with C# and a serverless application with F#. And it's like, wait, so there's a serverless project and there's a serverless application. What's the difference? There's something called the SAM, the serverless application model, I think is the M. But basically, it's a way that if you have a lot of moving parts and a lot of different triggers and maybe you're not an expert with the CDK or maybe you're not an expert in CloudFormation, SAM is a CLI tool that will help do this all for you. So what you get is, we spin this up real quick. I'll just click any of these. Hey, ASP.NET Core Web API, there we go. And then if we dig into here, then we can see things like, let's see. Yeah, so like this serverless template, and this is where it'll define all these different properties for your serverless backend and how everything connects. And if you're using ASP.NET Core, this will tell it where that entry point for your function handler is. So yeah, you can get really into the nitty gritty with this stuff. So everything's super customizable. And yeah, when we use these in like our real apps, we're probably not going to right click publish. We're probably not going to just use the default. We'll want to do it like this because yeah, like you said, if we want to have certain environments like tests, prod, QA, then we need to make sure those are repeatable and reproducible. So yeah, definitely want to go this route. So good question. Thank you. One more in the back. Yeah. Oh, yeah. So I mean, as .NET developers, I'm sure you see the blog post every year that Stephen Taub puts out about how much faster .NET 8 is over .NET 7. So like, that's one of the reasons why I always want to stay the latest greatest, because I can do nothing to my code and it'll run faster. We're talking. Oh yeah, so the cold start times. Yeah, if we jump back like I mentioned, the Lambda team does have managed runtimes, but they're only on the LTS releases. So that's .NET 6, .NET 8, it'll be .NET 10, I assume they'll name it. And if you look at these cold start times between .NET 6 and .NET 8, if we weren't using the custom runtime where we could take advantage of AOT, because AOT didn't exist in .NET 6. And so we'd kind of just be kind of sitting around waiting till, well, like now, like the Lambda team, if it's not this week, it'll be next week. We'll add the .NET 8 support for their managed runtime. But in the meantime, like we could have cut our cold start times in half. So yeah, like I said, for me, it's just a performance thing. I like to be on the latest, greatest because .NET 9 is going to be faster than .NET 8. And then you get these cool goodies like AOT that when I saw this, I was like, okay, that's easy choice, right? AOT my app right away because my app's going to load twice as fast. So yeah, you don't have to. And again, like maybe your application doesn't care, right? Like if it's an S3 trigger or a database trigger, or something that the user's not going to see, user's not going to interact with, where they create a new account, and then in the back end we have a database trigger that runs some code. Like they don't have to wait on that, so maybe it doesn't matter. But yeah, that's why I said like I always like using that custom runtime because I want to jump on the latest, greatest version, take advantage of these performance improvements. Good question. Yes.
What influences your decision about whether or not to have a server running full time compared to being serverless?
Yeah, I mean, for me, cost is probably the biggest thing. People don't want to pay for apps.
Let's say you got users the whole day. Like, I mean, do you think, okay, well, if I got 1,000 users per hour, then maybe I'd be better off having something on permanently?
Yeah, so I mean, that's kind of part of the game, right? Like, because when let's say Elastic Beanstalk versus AWS Lambda, Elastic Beanstalk, it's going to be, let's say we have an API running, it's going to be running 24/7, but we've also reserved those resources 24/7. So like I mentioned earlier, it's like paying rent. Like nobody else can use this CPU because I told AWS, like, that's mine, I need it. Whether or not anybody's using it, that's mine. So if you could get your Elastic Beanstalk app to basically run at 100% efficiency, then it's probably going to be a wash. But in my experience, I always, like before serverless was a thing, obviously I couldn't use it for my backends. And yeah, I would have to play this like scaling game with my backend where I would have to overestimate how much I thought I needed. And then I would have to tell AWS like, okay, if the CPU threshold goes above 80%, scale up and add another instance. And that would, that just all adds more and more cost. And so, yeah, I mean, this is why I love serverless, because if we can work around these cold start times, and now that they're down, like when this first came out, cold start times were like multiple seconds and it was really painful. So like I would do some animations in my app, kind of like do a little jig to distract the user, like, hey, look at this over here. Oh, okay, now we're done. But yeah, now that it's 300 milliseconds, I don't really care. So to me, it's really just more of a business decision. Like, is it really going to impact your users? Or are you going to lose money if this doesn't happen right away? Like maybe you're bidding on concert tickets and it's a limited resource and you got to get that bid in right away. Serverless probably isn't your thing because you might miss out on something like that. But yeah, cold start times, this is really the downside. But again, 300, 400 milliseconds, that's probably fine for most of us. Yes.
So if I understand correctly, I think there's ways of managing the cold start times. Like aside from the fact that they're almost certainly tolerable for 5% plus of your users, the first person that uses your app is going to hit that cold start time, and everyone else is going to get the warm start times, like you said. And there's ways of managing that, like you can analyze some trends of when people hit your app, and if if someone's hitting it at 6 a.m. every day, 5:55, you run a script that just wakes it up or whatever, right? So
Yep.
if I understand correctly, what you're suggesting is that the real difference between the decision to go serverless or non-serverless is your app in use 24/7. And if it's not, there's really going to be huge savings made by just going serverless, right?
Should be. Yeah. I want to say yes, but yeah, I'll catch you with the caveat so people don't come at me with pitchforks. But yeah, it's tough for me to think of reasons why I wouldn't want serverless, but again, like like Amazon with Amazon.com, and same with like Walmart.com, these online vendors, they've got numbers that say like every second that a request gets delayed, we lose millions of dollars. So if it is a business impacting decision like that, then okay, yeah, like 300 milliseconds is going to matter, but yeah, for the rest of us, probably not. Oh, sure, yeah.
Just like how long does it take? So if you go in serverless, how long does it take to scale up? Like if it only gives you one, for example, it's very quiet, and then all of a sudden you got 50 people coming on.
Yeah, that's a good question. I actually don't know the answer, but if I were to guess, I would imagine maybe that first instance would probably take about the same amount of time as a cold start, maybe a little faster. But no, I don't know. I don't have the data on that. And actually, let me show you something. Speaking of this data, so if we go to the website, codetraveler.net-serverless. So if you scroll down enough, you'll see the same chart, but obviously with more, I couldn't fit all of this onto the slide. All you have to do is click on this, and then this will take you to our GitHub repo where we keep this up to date. So, you might have seen that I had a little caveat on this .NET 8 because these numbers were actually back when the release candidate was around. So when that happened, the Lambda team actually found there was a regression in cold start times. Like that's why you might have noticed these numbers are like 50 milliseconds higher than .NET 7. It was just, I don't know exactly the details, but basically Amazon Linux 2023 just came out. And the way that worked with something in .NET 8 and that together caused a little bit of regression. The team actually had to open up a pull request to the .NET team. So it's all resolved now, which is why we had this delay in .NET 8 support, because they didn't want to push out what should be faster. And then everybody starts complaining like, hey guys, you screwed me. So that was a little bit of a delay. So these numbers will be updated. And then obviously when .NET 9 comes out, the preview literally launched this morning. I woke up to a flood of emails about it. We'll add the .NET 9 numbers. So yeah, make sure to keep an eye on this repo, star it, watch it, but you can find it all just by, on this website, clicking on this image, or if you scroll all the way down, the name of the repo is not super intuitive. It's called serverless.net demo. That takes you to the same repo where those numbers are. So I just wanted to share that with you because, yeah, you can keep an eye on these numbers, and maybe you want to do .NET 7 right now because those 50 milliseconds impact your apps. But no, good question. So it is lunchtime. I don't want to keep everybody, but like I said, I'll be around all week. If you see me, feel free to come up and chat. And thanks again for coming.